Hello everyone. Can you hear me?
Yeah, we can hear you.
Thank you very much. Good afternoon to all conference participants. Good afternoon to all participants of our section, Critical Data Processing System Modeling. I hope we can start our work. And the first of the participant can start in now. Yes?
Yeah, I can. If I recall correctly, the first one is my mathematical model of software development process. Is it correct?
Okay. Can you show your
Yeah, let me share my screen.
Thank you.
Okay. 1 second.
You.
Yeah.
Sorry. One moment, please. Can you hear?
Yeah, everything's working.
Thank you very much. We can start our conference. We can start our section. Thank you very much, our participant, and starting our work. The first report mathematical models of the software development process according to the outsource scheme. The participants of conference Serhiy Hlushko, Alexey Leonenko, and Ivan Mikheyev. Thank you very much. We can start.
Okay, hello colleagues. Thank you for an ability to present our work. Small disclaimer, excuse me if I'll do some minor or huge mistake at my first conference, such kind of conference, so I'm nervous a little bit. As mentioned on the slide, our presentation, our work is mathematical model of software development process according to the outsource schema. As was proposed by conference organizer, we divided our presentation in few stages. First of all, the motivation why we do our work and what is current state of the not market, but what is situation currently. Then our objective, why we do our research. Then steps which we done to receive these results and what exactly we were working on. Then share the results and our conclusions and a few further steps which we currently planning. If we speaking about motivation, we were planning to prepare the model of software development process to help managers to do right decision because there are multiple of aspects which influence this process. It can be a team collaboration, seniority level of members of the team, different client interactions, etc. So there are big amount of non-predictable aspects. And if we're speaking about current situation, we do research of many articles, materials, etc. But we, based on our research, we found the lack of probabilistic temporal characteristic in the model which were provided in the work. So we formulate our objective for research to construct a mathematical model which will analyze probabilistic temporal attributes of software development. process in realm of outsourcing. First of all, we start with modeling what is software development process, and we started from people, because basically people is the aspect which influences the most, and it's hard to predict. So we built the usual team structure based on our analysis and some information from the market. The next stage was we model the exact flow, what exactly happening during software development process, which let's say synchronize with team structure, and ways possible to go back in process of basically if some stages of software development process go forward, but in some cases it can go backwards and do one iteration or two iteration or whatever iteration. And this movement from some stage to stage can be with different heavy of the movement, because different people involved, different number of people involved, and complexity of this involvement. And after that, we start preparing mathematical model. We used GERT model and reformat our process to the graph based on GERT model, which also illustrate those forward and backward abilities to move from different stages of the process. And also we realized that if analyze the whole GERT model, the mathematical formula become huge. So we, in this work, do it a little bit easier for us. We split the whole flow to two stages: the software design, where the idea, the technical implementation idea was discussed, formulate, and make decision. And the second stage, it's code implementation and testing, to do it a little bit easy for us. So yeah, here is illustrated the W function, which is original one, which is huge, and it's tricky to work with it or hard to work with it. So we split it to one, and during analyzing of them, here is transition characteristic between stages in first left side of the flow, where is software design, and the formula is, as you see, a little bit smaller. It's easy to work with it, and normalized expression is also provided below. So as you can see, it's easier a little bit to work with it and analyze. And the similar information for the right side of the flow, it's about code implementation and testing. And in the same way, the expressions and normalized expression for the right side of the flow. And based on those information, we do the modeling in MATCAD to emulate it, the values to normalized expression we used based on expert opinion, at least in this work. We know that it's not the best approach, but we decided to do it in this iteration in such a way, and possibly in the upcoming work we'll use different approaches to receive values. And as a result, we received such values if we're speaking about expected value and variances for the functions for the software design stage and code implementation stage. And as a result, we received mathematical model which use probabilistic transitions to represent the movement between stages, and it help incorporate external experts, effectiveness of communication. So it uses probabilistic distribution to help somehow analyze this process, all of these not known or hard to estimate aspects of software development process. And we believe that it can help decision makers to use it, but we realize that it's only first stage of it, because we do such kind of split, as I mentioned, and also we analyze just the single sprint, basically single iteration of software development, but as possibly usually it's multiple sprints, multiple iteration, and mathematical model should be, I believe, even more complex, but it will provide more value. So for our ideas for upcoming work is to create a model which also incorporates these multiple iteration, multiple stages, which shown before. And yeah, in a few words, slides, it's our work. More extended version will be in text version of as a result of this conference. Possibly there are some questions, and I'll try to answer them.
Thank you very much. Thank you very much. Are there any other question from the conference participant? Are there some question? Okay, I would like to ask a question. How are the values of probability time characteristics presented by your obtained?
Do you mean from where we received those values for P?
Yes.
Or we, in this work, we used them from expert opinion. So from the person who is deep in this industry, and based on his opinion, use them. As also mentioned, it's not the best way, but currently we have only such values in time to be ready to this conference, and in future we are planning to use other values and check how our model will change based on other input values.
Thank you very much. How are the question from the conference participant? Okay, we have a question.
Yeah, thank you guys.
Thank you very much. Thank you. Thank you for the report. I hope the very interesting and topical subject of the report interested the conference participants. Thank you very much. The next participant of our conference will be researchers Serhiy Ignatyuk, Victoria Sidorenko, and Artem Poloshentsov.
Yeah, I will present the slides. Let me share my screen, please. Is it be okay if I will be present? It is written that if you will show your screen, your webcam will be disabled. Maybe something with internet connection. Is it be okay if My webcam will be disabled during the presentation.
Okay.
Yeah, because I don't know, some may, oh, I will try. Yeah, let me know if it will be disabled. Then I will be sharing the screen now. Yeah, you
Thank
can
you.
Yes.
see me or presentation.
Yes, yes.
Yeah, perfect. Thank you. So, hello, dear colleagues. I'd like to present you a study on the evaluation of the degree of investment attractiveness of IT projects. And we've done this study with my co-authors, Maxim Ludsky, Sergei Gnatiuk, Victoria Sidorenko, and Stanislav Yarovitsky. And so let's start. First, let's describe the relative of our study. And as we all know that Ukraine successfully showed the resistance to Russian invaders, and it is now clear that the future, Ukrainian future, is in Europe and in European Union and the other Western alliances. So it is now clear that after our victory, it will be really interesting for Western investors to invest money in Ukrainian, to rebuild Ukraine, and actually not only help to rebuild Ukraine, but also to make money on the attractive industries, because now we like in difficult time, and after the victory everything will be will raise, right? And beside that, we also have our internal national informatization program, which will support in finding IT projects and enhancing the investment landscape, right? And so why we conduct our study? Because investors should somehow choose which project to support, where to fund their money. And yeah, of course, it is much better to have some mathematical or some mathematical background on selecting the better projects to invest their funds. Yeah, and that is why we described the very important part in the selection of human factor in decision making and investment attractiveness process, right? And on the here you can see the different parts of decision-making process, right? In our study, we in that study we decided to focus on the block 4 preference system, which represent experts' preference regarding the indicators of characteristic of object of expertise. So actually, you will see on the next slide this chains of indicators based of what the investors can choose what project will be better for them, right? Also, what I need to mention that individual and group preference system should be mentioned. It's essential to recognize that both individual preference system and group preference systems they have well-established theoretical foundations, and during preparing our study, we conducted an analysis of such systems and the formation of this individual and group preference system. And in our study, we selected, I will show on the next slide which of them. And yeah, let's move on. To start our research, we proposed 18 indicators to assess the IT projects. You can see them on the slide. Actually, yeah, it was discussed with our experts. We invited 90 of them to assess each of the indicator to range them based on their opinion and form the individual preference system. And having done that, you can see the 4 chains of such formation, and a lot of experts showed a preliminarily similar result, and you can see that we have 4 chains, right? And 30 experts showed the similar chains of indicators. This one showed 12 experts, 11 and 6 experts. So, and as you can see on the first 3 of them, most experts think that we will, if we come back to the table, so they think that guarantees of return of funds to the investor and investment plan, it's important to them. And as it's as we show in our study, that will be much better to mathematically validate the result, that the IT project should be assessed exactly on such indicators, or some of them are more important or not. So, and that is why we should use the some methods to validate those results, and that is why our model for evaluating IT project of investment attractiveness was developed, right? And our model consists of 3 stages. Actually, the model have only 3 stages to make it more easier to understand, right? But the stages and the math, it is better to check in the text, and not to overwhelm your attention. On the first stage, we need to select our decision-making processes, and based on the analysis which we conducted in our study, we determined that it is better for us to use and compare 4 of them: Weld, Savage, Bayes, Laplace, and Hurwitz. And as I previously showed you 4 chains of the experts results, individual preference system, we will compare those individual preference system chains with the with those who analyzed by these classical decision-making criteria. And it will be done on the first stage. Let's briefly move through our decision-making criteria, and the Wald criterion is well accepted, well accepted criterion of extreme pessimism, guaranteeing conservative result in our group preference system, right? So, and the Savage criterion will be more democratic criterion that consider both majority and minority opinions in these group preference systems. And in iterative ranking, it will be similar. So the most significant indicator is determined, and the procedure should be repeated for all of our 18 indicators. The Bayes Laplace criterion will be an average of ranking across the decision-making matrix rows, taking into account expert opinion. And the iterative ranking, the indicator will be ordered based on their average ranks from the from experts' individual preference system. And Hurwitz criterion will be a more balanced approach to decision-making process. In iterative ranking will be done on the alpha value, and we used alpha as 0.5. Right. On the stage 2, we will evaluate the effectiveness of our decision-making process for IT projects by analyzing our group preference system with the individual preference system. And here on the left, you can see our chain, which was selected by 30 experts with 30 similar opinion of experts. And on the right, you can see that we use the world criterion to reveal the indicators in decision-making criteria. And as you can see, the result slightly different in the beginning and in the end. So if we on the next slide, we'll compare the actual result with other criteria, but what we can see on that part of the study that if we don't use our decision metrics and criteria, so the result will be different, and we will need to select the chain which is more mathematically validated. Right, then we move on to Savage criteria. This result, Savage and Wild criteria, looks almost the same, and that is why Savage criteria is just better in our study. It is just a bit better and more democratic. Yes, very similar to Wild criteria, and let's briefly compare with other. We also used Hurwitz decision-making process, and the result also a little bit changed, because the Hurwitz criterion more balanced approach to decision-making process, and it is more appropriate under the conditions when you have when nothing is known about the probabilities of occurrence of external states and the possibility of occurrence of these external states should be taken into account, or small number of decisions are implemented, and when you can some risk is assumed, when the risk is not zero, right? And so each criterion is suitable under some specific conditions, right? So Wild criterion suitable for one-time decision with no room for risk. Savage criterion more considered as democratic and suitable for some situation where you can add some risk-based Laplace suitable for scenarios with known and stable probabilities, and Hurwitz a more balanced approach for situation with some uncertainty and risk. Yeah, and the final stage of our model is to combine and to see which criterion shows more efficient way in our decision matrix. And as you can see on that slide, that really the result pretty I would say not similar, but results are close. Which why is that? Because we already identified just 4 methods and used them, and so if we would use like 10 of them, maybe the result will be more not that close. And the most effective for our selection is Savage criterion, which is really close to World criterion, but as it's more democratic, so it appeared that the small difference in this absolute value of R shows that indicators was selected appropriately, because we showed the final result with already good properly selected indicators. So that is why our result are so close, and our group preference system already was agreed upon this, and before that, and we had alpha on a small level. Right, so in conclusion, I can say that we studied 4 classical decision-making criteria: Wild, Savage, Bayes, Laplace, and Hurwitz, and we developed a model for assessing the degree of investment attractiveness for IT project. We compared these four classical decision-making criteria and selected the Savage criterion, demonstrated the exceptional efficiency by minimizing deviations and optimizing agreement with other group preference system. And we also already identified some open avenues for future research, and we already thinking about justifying trade-offs, determining normalized coffee indicators, establishing a reference group preference system, and maybe a little bit extending our method. That's it from my end. Thank you very much for your attention.
Thank you very much. Have a question, participant in our conference? Thank you very much. Thank you. Next report. I will do. I will do next report. One moment, please. I open my slides. Yes. Can you see my slide?
Yeah.
Thank you very much. Okay. Yes. The next report we did with my colleagues from Kyiv State University, Oksana Sitnikova, and Kharkiv National University of International Affairs, Kharkiv, and Victoria Roh, Kharkiv, Tatiana Kolesnik and Victoria Roh, Kharkiv National University of Internal Affairs. Topics the report: intelligent extraction of the informative features for UAV motion modeling, principles and techniques. The use of unmanned aerial vehicles is becoming increasingly relevant in various fields of activity. Some of the main reasons why UAVs are becoming more popular include: it is economic benefits. UAVs can significantly reduce the cost of performing various tasks. It is increased safety. UAVs can be used to perform tasks in dangerous or hard-to-reach places, such as disaster zones, forest fires, or search and rescue areas. It is increased efficiency. UAVs can accelerate task completion, reduce the time needed to obtain results, and improve data accuracy. It is real-time data collection capability. UAVs can be used for real-time data collection, allowing for quick responses to changing situations and effective decision-making. It is innovation. UAVs are a new technology that is constantly evolving and improving. The military sphere, the UAVs can use in reconnaissance and surveillance, in attack, in reduce personal risk, in communication, in training. Thus, the use of UAVs has a number of advantages and various fields of activity, and is an actual direction in the development of technologies. It is known that one of the main control systems of the UAV is the autopilot. This figure in the slide shows the components for the UAV autopilot. Although that specific equipment shown in figure is used for a small low-cost UAV, it shares the some components found
Sorry, Sergey.
larger.
You don't change your slides.
Sorry. And now?
Yeah, maybe it might be better if you run presenter.
Okay, I open next. It is UV autopilot components. Yes?
Yep.
Yeah, thank you very much. This figure shows the components for the UAV's autopilot. Although the specific equipment shows in figure is used for a small low-cost UAV, it shares the some components found in larger and more expensive UAVs. For example, more expensive UAVs might have more powerful processing units or satellite communication links. Next slide. Can you see? And next slide shows the UAV autopilot components in a data flow diagram. In this diagram, the components of the autopilot can be divided into three major parts which make up the GNS: guidance, navigation, and control. In this figure, the components marked in blue represents the communication and in and out of the UAV. The component marked in yellow represents the new ADS-B communication, and the component marked in purple represents the sensors that can aid the guidance of the UAV. I would like to draw your attention to the elements highlighted in yellow. This is a model technology for information exchange between aircraft, which allows you to inform about the location of the UAV. We have determined routes studying the data flow in the autopilot, several general cyber attack feasibilities. These attacks have been categorized into three groups: hardware attack, virus attack, and sensor spoofing. We have future identified specific attack scenarios which show the vulnerabilities of the current autopilot system. Looking at this from the cybersecurity perspective, it was natural to future categorize the attack into the following two types. It is control system security and application logic security. And next, the first question who we can use, who we can decide in our work, it is question modeling question and prototype work in modeling. Under the condition of increased requirements to accuracy and safety, UAVs in performing their task, a number of tasks of intellectual support of the control and life support system arise. Among such tasks, we can single out intelligent planning of the UAV flight trajectory under the influence of external factors. The goal of intelligent UAV flight path planning under the influence of external factors is to develop effective algorithms and strategies that will allow the UAV to adapt to changing conditions and ensure the accuracy and safety of its flight. Among the main tasks of intelligent UAV flight path planning, we can highlight the task of modeling the motion along the selected path. This task has found wide application in missions of automatic and semi-automatic following to a given point. I recommend optically taking into account external factors and influence its. In the context of intelligent UAV flight planning and the trajectory construction task, the main goal of the mathematical formalization stage is to ensure occurrence and consequently safe movement along a given trajectory. To achieve this goal, it is proposed to use variation autoencoders. An autoencoder is a natural network capable of learning the international representation of data and extraction its most informative features from the existing set. In the development model, a variable autoencoder can be used to reduce the dimensionality and reconstruction of the input data. This reduces the number of features and highlights important aspects of the data. The first step of data preparation for the variation autoencoders is data normalization. For this purpose, let us identify the main parameters describing the position of the UAV in space and affecting the accuracy of its movement when performing a flight task. As parameters describing the position of the UAV in space, we will emphasize the following: L, logistic range; H, height; V, velocity vector models; Q, velocity vector inclination angle; and hiding angle; and that lateral displacement and accordance with the characteristics of normal Earth coordinate system. Some work authors give examples of converting the normal Earth coordinate systems to the trajectory coordinate system. The trajectory coordinate system you can see in this slide. It is okay. Using the result, some authors with the rotation and transition matrix from the normal coordinate system to the trajectory coordinate system are described as form a basic of transition vector of the trajectory coordinate system to the normal coordinate system. The rotation matrices are of the form number 1. The transition matrix from the normal coordinate system to the trajectory coordinate system has the form number 2. The basic of transition vector of the trajectory coordinate system to the normal coordinate system has the form number 3. Accordingly, we have form number 4. Using the basic of vector 3 and expression 4, we can determine the characteristic of the UAV motion as a material point. It should be noted that it's determined by its kinematics characteristics such as position, velocity, and acceleration. The position of material point is defined in three-dimensional space using coordinately x, y, z, which indicate its location relative to some reference frame. The velocity of a material point is defined as the change in its position with time. It can be represented by a vector that indicates the direction and velocity of motion. The acceleration of a material point is the change in its velocity with time. It can also be represented by a vector indicating the direction and magnitude of acceleration. Coordinates of the UV velocity vector in the normal system we can see from formula number 5. The acceleration of the material point in the time differential of vector 5 we can see in formula 6. The motion of the UAV as a material point is determined by its initial state and the sum of external force represented by the coordinates f, x, y, and z, and the normal F coordinate system. If the vector f is decomposed in the trajectory coordinate system, be obtained in system f. According to Newton's second law, we can form a system of equation that determines the position of the material point in three-dimensional space 7. One of the most computationally difficult tasks is to take into account external influencing factors. Among such external factors, we can single out the force of gravity. This characteristic is not controllable. The other forces' action on the UAV can be considered controllable and can be represented as formula 8. We decompose the force vector into two components: the longitudinal load vector protection on the OX and the transverse load vector and Y protection on the OXY. A vector in the trajectory coordinate system using control parameters can be written as follows: 8 in taking into account the representation of forces acting on the UAV throughout overloads and adding 3 differential equations relating the velocity vector to spatial coordinates. We obtain the following system of 6 differential equations describing the motion of the UAV. How 9 formula 9, as can be seen from the system of equation 9, the control characteristics are not affine. They are not linear over the controls. At the same time, in order to normalize it and use it as input date in the variational autoencoder, it is necessary to transform it into an affine system. The conducted researchers have shown that for solving this problem in practice it is possible to use rotation, stretching, compression, and shear method. Using the rotation method and considering the variables as new virtual controls, the following relation can be obtained of formula number 10. Considering the factors given in model, we present the input data set of the variation autoencoder in the form of table. Next slide. It is variant autoencoder input date set LH. It is variant autoencoder input date set VQ. It is variant autoencoder input date set next and variant autoencoder input date set NX and Y. Three dense layers are proposed to solve the problem in this paper. After each layer, activation must be added to the encoder to introduce nonlinearity into the model. The activation function adds nonlinearity to the model and allows the neural network to learn complex dependencies in the data. In this paper, we propose to use the well-known activation function reactivity linear unit. The layer of mean values has a dimension corresponding to the number of latent variables. The paper proposed to create a layer of dimensionally free. The variance logarithm layer should also have a dimensionally corresponding to the number of latent variables. The output layer of the encoder is a layer that predicts the parameters of the distribution in the latent space. In the case of these characteristics usually means predicted the mean and logarithmic standard deviation for each dimension of the latent space. The encoder output layers in our task will generate the parameters of the probability distribution of the latent space, which will be used to future sample to the latent representation and generate output data. In conclusion, we can see that the use of UAV in the intelligent interaction of information future of UAV machine modeling and in UAV trajectory modeling has the potential to significantly improve the efficiency and accuracy of UAV flight planning and control process. The VIE is capable of finding hidden differences and structures in the input data. As a result of the study, informative features that characterize the UAV motion are automatically expanded and presented in a reduced but still meaningful format. Using the intelligent system, the dimensionality of the data has been reduced, which will further reduce the complexity of the calculation to analyze and process them using the selected base. In this context of UAV motion modeling, this has reduced the computational complexity by up to 13%. Thank you for attention. Have you a question for my report? Thank you for your attention. The next report. So we have participant Halina Podalko and Vasil Tomko and Dmitro Chumachenko. So Unfortunately, not all conference participants were able to join our forum. Okay, the next participant, it is Inna Petrovska, Nina Kuchuk, Maxim Почебут, Georgy Kuchuk, Alexander Можаев, and Yuri Onищенко.
Dear colleagues, our speaker has some technical problems. She tried to connect for our link, and she could join us in a few minutes. If it's possible, we will wait. Okay.
Okay.
Maybe next one.
It is finished. It is sex report. Yes. Sorry. Have you 1, 2, 3, 5 minutes?
Maybe 5 minutes. She will try.
Okay. Dear colleagues, we have 5 minutes to next report in our work hour section. When you have some question to our participant, we can ask this question.
Maybe somebody who will present reports after break and can show us presentation now.
Okay. 5 minutes, yes?
Okay, 5 minutes and
we have 5 minutes, dear participant, dear colleagues. We have 5 minutes to next report.
I saw Ina Petrovskaya join us, and Ina, your you share screen. You can start.
Thank you very much. Can you speak, Ina? So, dear colleagues, some technical problem we are checking in starting this report. The topic of this report: sequential series based.
Our speaker have some technical problems. That's why I will try to help her. And our report is a sequential series-based prediction model in adaptive cloud research location for data processing and security. Please, next slide. Ina, change slide, please. Next one. Yes. The demand for glue bills is growing with the skill fade. In this context, profiters and distributions are increasingly being exploited by various characteristics of drinks to poor research. There are a variety of additions to the real clock that provide high speed and efficiency. It isn't also necessary to process critical data, which results in increased productivity. In addition, in the remaining hours, there will be more widespread attacks on the standard situation of the gloomy proceeding in various maliciously cyber activities. In this context, an effective method of distributing researches can play a key role in providing essential service. This method is designed to ensure the prompt service of all mitigate transactions and drawing of researches to guarantee the efficiency of customer service. Increasing the productivity of employees and maximizing the satisfaction of deputy employees. A promising approach to the task of efficiently distributing wealth for researchers is to model the process of placing virtual machines. It's a mathematically rich optimization problem. Next one, please. Next slide, please. Developed adaptive forecasting model for cloud research allocation is presented. It employs principal complement analysis on a sequence of virtual machine requests. Requests are processed to detail anomalies and adaptive predictions are computed using EMD ARIMA or EMD RT ARIMA methods. The choice between these methods is determined by comparing the exclusion time values with threshold value. This adaptive approach enables the selection of a prediction method based on data characteristic and researchers' demands. To optimize the selection of the RTD threshold, the impact on actually and time costs is examined. A quartile method is it used to detect dynamic speakers, and cubic spline intertolerant is employed to smooth data. Calculations of time costs insights that this method reduces forecasting time by extracting core component sequence. Please, next slide. Ina, change slide. Next slide, Ina. Ina, do you hear us? On this slide, you can see a structural diagram of the method of adaptive distribution of researches. It consists from 4 parts, which presented or shown on the slide. It's analysis of primary data, basic forecast of future dream, and for researchers. Next one is proceeding researchers requestment. Okay. On this slide, you can see a schema of the method of adaptive forecasting based on the series sequencement test. It's You can see a presentation of this sequence test on this slide. And we go to next slide. Ina, change slide. Ina, next slide, please. Okay, yeah. Our conclusions of and future work of this. Thus, a prediction model based on a sequential series has been developed for the process of adaptive cloud research allocation. And outstanding feature of this model is the consideration of extra-manual in futures when calculating the characteristics of cloud research requests and predicting research demands based on a sequential series test. This model approach allows reducing the prediction time by accepting the main components exactly by 1.5 times. To ensure time research allocation, the NSG 2-second algorithm has been enhanced. This has led to a 5% reduction in the solving time of the multi-objective optimization problem. The researcher findings also demonstrated that the effective utilization of different types of resources on a physical machine reduced loss by 1.2 times compared to the spree second and NSG second methods. Thank you for your attention. If you have some questions, you can write, and our speaker will ask you. We told you on the chat. Thank you.
Thank you.
I saw Halina Padelka join us.
Yes.
Hello, guys.
Good day.
Ina, close your presentation.
Yes. Next participant, next report will be a report from Halina Padalka, Vasil Homko, and Dmitry Chumachenko. Dear colleagues, are you ready?
Yeah, sure. I will be speaking on behalf of my colleagues. Let me share my presentation. Give me a sec.
Nina, can you check your... Can you stop your presentation? Thank you. Thank you very much. We have to study. We can study.
Yeah.
We can start in.
Yeah, I see that I'm able to share. Give me a sec.
Okay.
Can you see my screen?
One moment, please. Yes.
Okay.
You can see, but it is...
Yeah, let me do it full screen.
Yes. Thank you. Thank you very much. We can start in. Thank you.
Oh. Is that okay?
Yes.
Okay. Good morning, dear colleagues. My name is Elena Padalka. Today I will be speaking on behalf of Dmitry Chumachenko and Vasil Chumko, representing our research COVID-19 misinformation detection and Weibo by support vector classifier. So, the COVID-19 pandemic has unleashed the parallel infodemic characterized by the overabundance of accurate and false information on the internet and social media platforms. This infodemic have been fueled by the global concern and uncertainty supporting of the virus, leading to the rapid dissemination of misinformation and disinformation. So our study aims to develop a support vector machine model for classifying misinformation related to the COVID-19 pandemic shared of the Chinese social network Weibo. We used check data set for the application of the misinformation classification model. This comprehensive collection of the microblogs from the Chinese social media platform Weibo was curated explicitly for COVID-19 misinformation detection. It is actually the first of its kind focusing on Chinese language content related to the COVID-19 pandemic. The dataset comprises two main categories of microblogs. First of all, is fake news and also real news, each containing several entries. Each entry in the dataset includes a variety of components such as microblog's ID, label by researcher like a real, fake data, posting date, user ID of the poster, textual and visual context of the microblog, a number of comments, forwards and likes, detailed information of the user comments and forwards, and an expert actually analyzes and justification for the label. It is only for microblogs, which was determined as a fake. In addition to the microblog entries, the dataset includes a list of keywords used to determine the relevance of the microblog to COVID-19. So the check data set is a valuable resource for researcher working on misinformation detection, particularly on Chinese language, because we are not expert in Chinese language, you need to acknowledge that, and in the context of a COVID-19 pandemic, which we are very much delighted and interested in researching. It provides a robust and privacy-respecting collection of the real and fake microblogs, expert analysis, benchmark results, and additional resources to facilitate further research in this critical area. So let's go to support vector classifier. It's a type, and we will call it SVC model further. It is a type of support vector machine used for classification tasks. It is a supervised learning algorithm based on the concept of decision plans defining decision boundaries. A decision plane separates between a set of objects having different class membership. Mathematically, SVC algorithm try to find the optimal hyperplane that separates classes in a feature space, as you can see it on the slide. The feature space is n-dimensional space defined by the n features used to represent each data point. The hyperplane is defined as n one-dimensional points. The hyperplane one n-dimensional subspace of the feature space. For a two-dimensional feature space, the hyperplane is a line, and for a three-dimensional feature space, it is a plane, or so on. The optimal hyperplane is the one that maximizes the margin between the two classes. The margin is defined at the distance between the nearest data point of each class to the hyperplane. The data points that are closest to the hyperplane are called support vectors. That's why we call it support vector machine approach. As a support vector are critical elements of the training set because they define the decision boundary. Any data point of the side of the hyperplane is classified as one class, and any point of the other side is classified as the other class. And as you can see it's on the slide, definitely. The SVC algorithm was adapted for misinformation classification using data from Weibo, a popular Chinese microblog web service. Weibo posts often contain a mix of text, images, and videos. Therefore, the feature extraction process must be adjusted to handle this type of content. In the context of Weibo, the feature space can be a set of the features extracted from the text, image, and videos of the Weibo post. For the text data, features can be extracted using the term frequency, inverse document frequency, TF-IDF values of words on the n-grams, sentiments, scores, or etc. The classes to be predicted are binary, for example, like fake news or real news, as I said previously. The SVC algorithm have trained on a label data set on a Weibo post to find the optimal hyperplane that separates the fake news posts from the real ones in the feature space. Once trained, the model can classify new posts into fake or real categories. The process of model tuning involves several critical steps to ensure optimal performance. Initially, various models were tested by alerting only the kernel function and critical parameter in the SVC models. Among the different kernel function tested, the linear kernel emerges as the most effective, the most efficient, I would say, demonstrating superior performance in the preliminary trials. Subsequently, the comprehensive search was conducted for the optimal values of the remaining parameters. Specifically, the regularization parameter C and the kernel coefficient G, utilizing the grid search approach with a tenfold cross-validation. The grid search was performed across the range of values with a spread of the order of magnitude. 0.10 for each parameter. This approach ensured throughout exploration of the parameter space and ultimately identifying the most suitable parameter values for the model. Prior to the execution of the model, it was imperative to select an appropriate vectorization technique to convert textual data into numerical formats suitable for machine learning algorithm. After careful consideration, the FTIDF vectorized was chosen for the two primary reasons. The TF-IDF vectorized is seamlessly integrated into scikit-learn library, eliminating the need for additional post-processing. And second is, among the various non-deep learning based vectorized evaluated, the TF-IDF vectorized exhibited the best performance on the generic SVC model concerning particularly F1 score, even without parameter tuning. This metric is critical as it provides a balanced measure of the model precision and recall. The model tuning process involved a systematic approach to selecting the most appropriate kernel function, conducting a grid search to identify the optimal values for the regularization and gamma parameters, and choosing the most effective vectorization technique. The selection of the linear kernel, the comprehensive grid search, and the TF-IDF vectorized collectively contributed to developing robust and efficient model of the task at hand. The performance of the model is presented in Table 1. This metric comprehensively assesses the model's ability to classify fake and real news articles almost correctly. The confusion matrix is a table that displays a number of true positive, true negative, true false positive, and false negative predictions made by the model. It provides a detailed view of the model's performance by showing how many instances of each class were correctly or incorrectly predicted. The confusion matrix is presented in the left figure. You can see it on a slide. The normalized confusion matrix is similar to the confusion matrix, but the values are normalized with the number of instances in each class. It provides a clearer view of the model's performance by showing the proportion of instances of each class that were correctly or incorrectly predicted. The normalized confusion matrix is actually presented in the right figure. The learning curve graph displays the model's training and validation performance as a function of the number of training samples. It helps to identify if the model is suffering from overfitting or underfitting. Overfitting occurs when the model performs well on the training data, but poorly on the validation data, and underfitting oppositely occur when the model performs poorly on the training and validation data. The learning curve is presented on the slide. You can observe it. The false positive rate versus threshold graphs display the false positive rate as a function of the decision threshold used by the model. It helps to identify the optimal decision threshold that minimizes the false positive rate with a maximum and as a true maximizing actually the true positive rate. False positive rate versus threshold graph is presented in a figure. You can see it on the slide right now. The results indicate that SVC model performed well in classifying COVID-19 fake news on Weibo platform. The model achieved an accuracy 89.07% and the F1 score of the 87.33%. The confusion matrix and normalized confusion matrix provide detailed view of the model's performance, showing that the model correctly classified a high proportion of instances of each class. The learning curve graph indicates that the model did not suffer from overfitting and underfitting. The false positive rate versus the threshold graphs help to identify the optimal decision threshold that minimize the false positive rate with maximizing the true positive rate. So let's move to the discussions. The result indicates a relatively strong performance of the model in classifying COVID-19 fake news. The model's accuracy is 89.07%, and the F1 score, harmonic means of the precision and the call, is 87.33%, indicating a balanced model performance in precision and recall. However, the model's specificity is only 58%, which is unfortunately relatively low. The metric correlation coefficient is 0.6264, considered as a moderate correlation. But nevertheless, the balanced accuracy of the model is 22.29%, which is average of the sensitivity, which means recall and specificity. Classifying COVID-19 fake news on a Weibo platform has several significant challenges, so let me talk with you about that. One of the primary challenges is the language and the cultural nuances associated with the Chinese language, which present unique challenges for the text processing analysis. Cultural nuances for the context-specific references may make it difficult for the model to classify the context accurately. Additionally, the data set is often imbalanced with more real than fake instances, leading to the potential bias toward classifying news as a real, affecting actually the model specificity. Another challenge that I also need to acknowledge is the detection of sarcasm and humor, which is the model often misclassified as either real or fake news. Sarcasm and humor often involve a play on words or like a double meaning that may not be immediately apparent to the model. The quality of the label in the training data set also critical for the model performance, as you can understand. Inaccurately labeled instances in the training data can lead the model to learn incorrect patterns, resulting in suboptimal performance. The variability of fake news also poses a significant challenge. Fake news can vary widely in content style and presentation as well. Some fake news articles may be entirely fabricated, while others may contain a mix of true and false information, which is also extremely important challenge. This variability makes it challenging for the model to classify fake news accurately. Additionally, the nature of the news and information changes rapidly, especially during the public information crisis, as like COVID-19 is. The model must be robust to these temporal dynamics and accurately classify news even as the situation emerged so fast as it was in COVID-19. Feature selection is another challenging aspect for this task as well. The model must be considered various features such as text, images, user interaction, for example, comment, like, repost, to classify news accurately. However, incorporating too many features may lead to overfitting, while the too few features may lead to underfitting. And lastly, model interpretability is paramount to understanding the model's decision-making process and ensuring that it's not biased and make decisions based on the relevant features. However, achieving the high model interpretability while maintaining high classificational performance is also challenging, so we need to count on that and find the best balance. So let's go to the conclusion. The study's main finding indicates that the developed model exhibits strong performance in several key metrics, including accuracy, F1 score, recall, and precision. However, the model specificity and Matthew's correlation coefficient, as well as balanced accuracy, highlight areas for improvement, particularly in reducing false positive rate and improving the model's ability to classify real news instances more correctly. The novelty of the study lies in its focus on the Weibo platform, one of the most popular social media platforms in China. It has not been extensively studied in the context of COVID-19 misinformation detection. Future work should improve the model's specificity and overall classification performance. This could be achieved by incorporating additional features, optimizing model architecture, or fine-tuning the model's parameters. Additionally, the future studies could explore using deep learning models and other advanced machine learning techniques to improve the model performance further. It would also be beneficial to evaluate models' performance on other social media platforms and in other languages to assess generalizability and applicability in different contexts. In conclusion, the study presents a comprehensive approach to classifying COVID-19 fake news on a Weibo platform. The developed model exhibits strong performance in several key metrics, but also highlight areas for improvement, as I mentioned before. The study contributes to the growing literature on COVID-19 misinformation detection and provides valuable resources for researchers and practitioners. Ultimately, the accurate and timely detection of COVID-19 misinformation is crucial to ensure that the public is well informed and can make decisions based on accurate and reliable information. Our research on the COVID-19 epidemic underscores the importance of addressing the issue to safeguard public health and promote accurate information dissemination. It is imperative for stakeholders, including government, public health organizations, social media companies, and the general public, to collaborate and implement strategies to combat misinformation and ensure that accurate and reliable information is accessible to all. Thank you. I'm going to stop here.
Thank you very much. Thank you. It is very interesting and very interesting, very actually topical subject of the report. Have you question, dear colleagues? Have you question? So thank you, Galina. Thank you, colleagues.
Mr. Samanov.
Thank you, dear colleagues. We have some time to the lunch. We have some time to the lunch, 15 minutes. And the next article, next report, we will be due for one in plain at 14th. Yeah, no, 14:45. Next will be plenary session. Thank you very much.
Thank you so much. Enjoy conference.
Thank you, Galina. Thank you. Goodbye. Good luck. Dear colleagues, we have some time to lunch, to coffee break for next report.
is the moderator here. One small question. Is report 7457 was presented?
Sorry. Can you repeat it, please?
Is report 7457 was presented?
Report number
7457.
57. One moment, please. 7457. One moment, please. 7457. Yes. Now will be. Now did.
So
Halina Padalka, Vasil Homko, and Dmitry
So it
Tymoshenko did this report.
okay, so no problem. Thank you.
Thank you.